This is Kelly Hill, technology reporter for RCR Wireless News. I'm here today with Nick Carter and Nicola Logley of Aeroflex. I'm sorry, it's not Aeroflex anymore. It is Cobham Wireless, and formerly Aeroflex. And we're going to be talking about some of the testing approaches that they do, and as well as some of the current trends in terms of HetNets, VoLTE, MIMO, and a few other topics. So welcome, you two. And I wonder if we can start out with a little bit of an overview in terms of how Cobham Wireless approaches testing, particularly for HetNets, and maybe some of the trends that you see in that area.
Okay, so in terms of the HetNet trends that we're seeing, what we see is very much a combination of the use of some of the existing legacy technologies like GSM, WCDMA, coupled with the kind of leading edge LTE advanced. So we see a lot of interest, for example, in carrier aggregation of TDD and FDD technologies for LTE, and then how that works in a kind of real-world environment where you also have fallback to technologies like WCDMA or potentially GSM.
Okay, great. Talk to me about at what point in network and device testing your solutions get used. What are the pain points that people are trying to avoid or address when they use your testing?
Okay, so we offer a kind of end-to-end test solution which is aimed at network equipment vendors who develop network infrastructure for mobile telecoms. So, for example, tier 1 vendors, semiconductor manufacturers, small cell developers. Plus, we also offer the same solution to operators who are looking to validate the technology which they're rolling out. So, ours is very much a solution which is used to validate end-to-end performance in a kind of controlled environment in what I would say is a kind of realistic environment as well, because what we're trying to do is ensure that at the end of the day that the functionality and capabilities which are being rolled out by operators function as advertised and as claimed. So this is a combination of validation, regression test operation, end-user performance measurement, and this is done on a kind of considerable scale. So we're not just talking about potentially mimicking one user device, we're talking about potentially mimicking tens or 20,000, say, different devices that may be operational on a network.
Okay, great. Now, Nick, you mentioned FDD and TDD carrier aggregation. I think we're seeing a lot of interest in carrier aggregation as a technology right now, as a feature of LTE Advanced. We're starting to see deployments of 2-carrier component. We're also seeing some testing advances in 3-carrier component even. So what are some of the challenges of carrier aggregation testing as you see it, particularly when you start talking about combining FDD and TDD?
You want to have like
Yeah, so in general, as a carrier aggregation, I think there's one of the main challenges is the scheduling of carriers, and right away your equipment or your system is handling the traffic scheduling in the most efficient way as possible. Adding on top of building on top of the same duplex scheme carrier aggregation and migrating to multi-duplex scheme carrier aggregation, the challenge is to put together 2 different technologies with 2 different ways of computing and multiplexing and feedback in the channel feedback, and also having 2 different propagation models across the two duplex schemes, and so having 2 different propagating over the radio channel and emulating the channel conditions.
Okay, and I gather that those are fairly complex. As you start to move into this type of carrier aggregation, that it's a very complex radio environment.
Yes. On the other hand, though, the reason why it's so appealing is because it allows operators to make full use of all the chunks of spectrum that they have.
Yeah. So hopefully better efficiencies.
Yes.
Okay. Speaking of complicated, I'm wondering what you guys are seeing in terms of MIMO. You know, I was just at a conference, LTE America, last week. There was a lot of talk about not just 2x2 MIMO, but 4x2 MIMO, you know, and what it means for the radio environment as we start moving to some of these higher order MIMO schemes. What are you seeing in that area?
I would say yes, we're seeing a lot of demand for higher order MIMO schemes, and it plays into the same theme of the complexity, really, of the radio interface is increasing. And although on our side we provide the UE simulator, which effectively drives the network, when you put yourself in a position of actual real handsets and the device you have to develop it, then it's another order of magnitude when you're trying to put this into an actual UE itself.
Yeah. Yes, and it's, despite having been specified in the release 8, the 4 layers transmissions like 4x4 have been kind of sleeping until now, while people were deploying LTE and focus on the basics. Now there's a demand for higher throughput, and so like 4x4 is 4x2 and 4x4 are coming out. And on the other hand, we see already lots of pull for also MIMO's increased order MIMO in conjunction with the new transmission modes from release 10 onwards, like transmission mode 9, where the customers are combining MIMO schemes and beamforming to exploit on one side the spectrum efficiency, on the other one also the interference management and a better multi-user MIMO exploitation.
Okay.
So I guess, again, for companies who are looking at trying to validate their solutions in a kind of real-world environment, it plays back to the importance of having features such as the ability to have channel models which can vary by different UE type and can play into these different order MIMO schemes.
Okay, great. Nicola, you mentioned interference, and I think that leads nicely into my next question, which is, you know, what are you seeing in terms of testing related to interference for small cells? We talked a little bit about HetNets, but I'm wondering about small cells specifically. We have the EICIC, the Enhanced Inner Cell Interference. You know, that is a feature of the standard, and I'm wondering what you're seeing in terms of, you know, are people testing for this? Are they trying to deploy this? You know, what are you seeing explored in terms of dealing with interference in small cells?
Yes, we see lots of interest rising around this, the interference management in general, and some specific features that are like on one side intelligent user beamforming, on the other side features like the EICC, as you were mentioning, and this is due to the fact that there's an increased use of small cells, or intention to use small cells, and it's also in what will be planned, properly planned the network scenarios, and the interference is really the enemy to beat, and the things in which the network vendors and operators are shifting their attention to. Because this in HetNets scenario where you have a mix of small cells potentially close to each other and macro cells that interfere by definition with the rest of the cells, this is if all these technologies deployed without any attention to the interference management, this becomes a very suboptimal solution.
So I guess one of the things that, again, you might want to test from a deployment viewpoint is what the impact of interference, if it takes place, actually has in terms of a given scenario, in terms of the end user experience, and then to what extent it can be mitigated by some of these technologies when effectively you can switch them on.
Okay, great. Just one final question. I know that that you guys do some in terms of validating for VoLTE. Can you remind me, what you do in that area? And I don't know if there's anything in particular you're seeing in terms of device validation. Are we seeing that ecosystem expand?
Okay, so what we do is we have a end-to-end VoLTE solution, which is part of our real data application suite of capability. And effectively what we do is we're able to make calls between different simulated devices within our system to other devices, and then kind of perform qualitative experience type measurements on those calls once they're up, whilst driving kind of mobility scenarios, whilst driving perhaps different traffic scenarios within the same cell. So we're able to play with factors such as cell loading, the environment, and so on, to actually mimic a given scenario and test whether the VoLTE call is actually performing as expected, and you're getting the expected quality that the user would expect from that call. And we can do that from a very simplistic scenario, just with, say, a couple of handsets, all the way through to, as I said, kind of thousands of handsets ultimately. And the interesting thing here is when you start plugging in some kind of real-world scenarios where you've got mixes of users, you've got perhaps groups of users traveling, and you actually want to say, okay, well, as the cell loading goes up, what's the impact on the VoLTE users? Because you've got some key real-time requirements you've got to meet to keep your VoLTE call up. And if your cell suddenly gets loaded by other users doing video calls, well, what's the impact on your VoLTE users, for example? Does it perform as you would expect? And then you've got scenarios, obviously, around the fallback to legacy networks as well. So you've got the whole impact of SRVCC, for example. What happens when you need to fall back onto a circuit switch network? Does it work as expected? Do you get an interrupt in the quality? Do you get a noticeable change in quality, for example, when you do a fallback?
And that reminds me, we've had some announcements recently from carriers in the US that they're going to be working on VoLTE interoperability. Is that something that that your solution could be used for as well, or is it primarily focused on whether VoLTE works within a carrier's network as opposed to between carrier networks?
It's focused on ensuring VoLTE operation works with whatever the configuration a given carrier has. Okay, so that includes their core network infrastructure in addition to, obviously, the kind of end-user devices. So that's as far as we go in terms of our VoLTE solution. So it effectively allows them to validate a benchmark to ensure that, yes, the system fundamentally works. Okay. There's then another dimension on top of that, which is the actual handset variable itself. So when a new handset comes out, is that performing as you might expect? And then you've obviously got, on top of that, interoperability with other carriers' networks as well.
Okay. Great. Well, gentlemen, thank you so much for the conversation today. We appreciate the insight. I've been talking with Nick Carter and Nicola Logley of Cobham Wireless. Thank you so much.
Thank you.
Thank you.